facing done with the face toolpath and a depth repeat. What tool do I want to profile my part with, rough profile my part with?
The roughing tool.
The roughing tool, the same one I faced with. All right, tool 1. So, do I need to put a tool change in here if I'm going to stay with the same tool? No, I don't need to. I'm going to because I want it to stop. And remember, every time I say actual tool change, it's going to do an M01. So my technique is, yes, I'm going to add a tool change, but I'm not going to change the tool. So I need to go back to insert. I'm on.
Can we see it on the big screen?
Thank you. I assumed everybody could see on the screen. I'm on operation 9, below where I want to be. Insert page. I'm going to insert a tool. I'm going to insert the same tool. I'm not changing a doggone thing. I've already set up what this tool can do. And I'm just going to hit accept. So that's cool. That's going to give me an op stop at that point so I can inspect my part. Okay, the next tool path to rough profile my part, we are going to go back. We're still in insert mode, as you can tell by this box here between operation 9 and 10. We are going to go back to cycles, can cycles.
What number is that?
I will escape once. Can cycles are F5. Okay, we're not drilling, boring, tapping, facing. Rectangular pocket is an inside move. Circular pocket is inside move. Frame is what we want. Frame. All right, so I clicked on frame, and it brought up all these questions. For starters, frame type. Right now I see outside rectangle. I'm going to hit the space bar, or I'm going to hit F3. Inside circle, outside circle, inside rectangle, outside rectangle.
How are the inside ones different from the pocket cycles?
It's the, what's the difference between frame and pocket? And I believe it has to do with the material clean out. Okay? How much stock is in the, a couple of the questions that has to deal with cleaning out stock. Okay, so we are going to start with outside rectangle. Now, this tool path is why we put our work coordinate system in the middle of our stock. Because we're going to define our frame, this rectangle, from the center of the rectangle. So I come down one page, or one line, and position type, center or corner. So I can define this frame by starting in a corner or starting in the center. And I'm going to start in the center, man, because my work WCS is in the middle of my part. Okay. Any questions on that? Let's come down to center position. Do you see any incremental after the X and Y center position? No. What does that mean? It means it's absolute. And it's absolute in reference to what? My G54. So I put my G54 in the middle of the stock. So what numbers need to go in center position X and Y? 0, 0. There is no difference between my G54, X0, Y0 than the center of this dude. Sweet. Where is the surface height now in relationship to G54 since I faced my part? It's at 0. It is at G54, Z0. So those are pretty straightforward. Now for the hard part. I now need to define the length and width of my vice jaw. Now, we mentioned a minute ago where our machining decisions are to rough and then finish. And we need to leave roughing material behind. Question is, how much roughing material do we want to leave behind? One of the differences, a couple differences between our rough and finish of the profile is we're going to be making depth cuts with our rough tool, but our finish tool is going to be full depth. So 0.745 of axial engagement on that cutter. Now we have to figure out our radial engagement, how much our step over is going to be. And let's do this. Let's start with a 5/1000 radial engagement, which means I need to add 5 thou to both sides of my part. So, I wish I would have had my print called up on the screen here. Let's see, how hard is it going to be to call up my prints? Oh, super easy, barely an inconvenience. Okay, so the length of my part is 6 inches. So I need to add 5 thou on both sides of my part. So what is my ultimate, what is my rough length?
6 inch, 10 thou.
6.01, good. In Y, I want to add 10 thou. So what's going to be my thickness in Y? 1.765. 1.765. All right, let's go back to our program. So in X, I'm going to go 6.01, 1.765 in Y. That's going to leave 5 thou on both sides for finishing. Radius. Interesting thing about the radius, my part doesn't have any radius call-outs on the corners. If I don't put a little radius in here, when it gets to the corner of this frame, it's just going to make a sharp 90, which after this part gets ground is really going to be gnarly. So we're going to put a 30/1000 radius in here, 0.03. Okay, total depth. Now we made this, let me see if I can get back to, so my part thickness is 0.755. But remember, my roughing tool has a 30/1000 corner radius on it. I need to go deeper than my finished part by 30 thou. So what is going to be that Z number? 0.785. 0.785. So it knows the total depth I want to go. Now it's asking me, okay, how much do you want to go each pass? And since my radial engagement is going to be about 25 thou, that's not very bad at all. We're going to go for a 200 thou depth. 0.2. Plunge rate. Well, before we do plunge rate, plunge type, we do have a choice. I'm hitting the space bar or F3 to toggle. And I do want to ramp. I don't want to go straight. Now the reason I'm calling this out is unlike our previous plunge, this one is going to be cutting. So let's cut during our plunge at the same feed rate we programmed for our tool, which is 22 inches a minute. We are going to ramp, and I guess we're going to start with leaving it at the default 45 degrees and see how that looks and sounds. And that is the ramp angle it's going to go at. Do we cut conventionally or climb? We climb. Why do we climb? We climb because it gives us a better surface finish. It's easier on the tool. The machining forces are less. The chip goes from thick to thin, thick to thin. So if you can, you climb cut. When you were learning manual machines, you didn't climb cut because you didn't have ball screws like we do now in the axis would feed on its own and blow out your cutter. So when you're in manual world, you're doing conventional. You have to fight that lash all the time. But in the CNC world, folks, climb, 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 unless there's a reason not to. So toggle to climb. All right, feed rate is at 22. That carried over from previous toolpaths. Let's do a graph from the front. We're not seeing a whole lot yet. Oh, there's our face. I'm going to turn this up a little bit. Ooh, boy, it went real quick. Okay, so we saw our face up here, and then here are our depth cuts with the profile. And this is that 45-degree ramp for the lead-in to get to each depth. Let's go to the top now view. So while we're here, we're looking for Z, folks. Remember, we do not want to get into our work holding. So we have 60 thou. We did all these decisions before about what. So from Z0, we're taking off just under 75. So we still should be having our clearance between our 60 thou of our Talon grips and our part. So always look at Z and always make sure you're staying out of your work holding. Let's go to the top. Those big round corners, that is what a 30 thousandths radius looks like at the center of a 1-inch cutter. Okay? All right.
That's not going to actually, I mean, we're not going to round off our corners that much, are we?
That is what a 30 thou corner rad looks like at the center of the cutter. So the center of the cutter is taking a larger arc, but that a ½ inch away, the arc is at 30 thou. So it does not look right, but it is right. Okay, so there's our rough frame. Going to accept.